grade.
Yes.
Do you guys love the beginning of homework that's just filling in properties?
I love it so much.
Whoa! Who is this guy? You have sine, cosine. Is that some indifference of a sine or a cosine? A sine, because they're not with it together. That's a cosine. And sine, so sine theta, same. So this is a sine of u minus b, and this is a cosine of u plus b. Changes. This is the tangent of, wait a minute, sine over cosine, same over change, tangent of u plus b. Don't worry. On Monday, aren't I giving you the left-hand side and you're giving me the right-hand side? So you're filling in stuff like this.
Wait, Monday? It's Monday?
Yep.
Is it all of it or just parts?
But you were gone yesterday and you were gone a lot. Monday is the formula portion of the test where I give you category names in order and I choose as many as I deem necessary or whatever.
Wait, is it matching?
Nope. I give you the left with an equals with a blank and you fill in.
So you give us the name of it?
I give you like video from yesterday, but I give you something like quotient properties,
Okay.
and then I give you something like tangent of u or theta or x equals, and you have to tell me what. So I'm always giving you the left-hand side of any of those formulas, and you're always filling in the right, but I'm not going to give you every single one of every single category. I'm just going to give you a few.
Okay. I'm just confused when you say left-hand side. Like,
Oh, and you guys can be grading number 14, right? Let me try to zoom in a little bit because it's really small.
Why is it?
Can you see it a little bit better?
Why don't they multiply?
Well, check it. They could have written it like this, right? Root 2 minus root 6. They could have written it like that. They just saw that there was a comma that they decided to pull out.
Why did at the last step? Why did they multiply it? Just gave you.
Well, that's what I just said. They could have written this root 2 over 4 minus root 6 over 4, and that's right. They just saw there was stuff in common that they could just pull out. So they pulled out the root 2s, they pulled out the over 4s, and they wrote something nice in between. So they chose the factor. You could have chosen to multiply. Jade, what I'm showing right now is what I showed them yesterday at the very end of the chapter just for illustration, which is probably similar to a lot of their formula sheets. It gives you all the formulas from 5.1 and from 5.4 and 5.5. And what I told them is this very last box, you don't have to memorize those. I will put all of these on a handout for Tuesday, the problems, so you can use them all. But Monday is when you're filling in. And when I mean the left side, all of these have a left and a right. I'm never going to give you this and you fill in. I'm only going to give you these and you fill in.
okay, what about,
And I give you
okay,
these.
so these are all for those ones. What about like, for these ones, it'd be like that and then that. Okay, yeah, I see.
So I'm not going to like mix it up.
Oh, thank you. And it's just the last part that we know. Everything else is pretty much.
And once again, not giving you every single one, but
Yeah.
you should study. Right before the test.
392.
So, for those of you that didn't catch what Sophia was saying, another way of writing this answer could have been root 2 over 4 minus root 6 over 4. That's another way of writing the answer. For this one, root 6 over 4 plus root 2 over 4, you were not wrong. And then this, sorry, no, you had to simplify. You had to do like a common denominator, and then you had to do multiplying by a conjugate to make it look pretty. But before multiplying by the conjugate to rationalize the denominator, you would have gotten, I think, root 3 minus 3 all over 3 plus root 3. Oh, wow, that's a lot like yesterday. It's like almost the same. Then you have to multiply by the conjugate top bottom to get rid of that square root and make it.
That's expensive. Right?
Number 30 should have been awesome.
Yes.
Like if you see that in the test, you should be like, thank you, Jesus, because I'm going backwards to a nice little done.
That's a lot.
Wait, done? Yeah, because I mean technically you're not really using your calculator. Oh, maybe you're not using your calculator. So you can just stop there and be done and make it match and be like, it's not unit circle. How could I keep going? So you guys saw in homework, right? Sometimes forward, sometimes backwards. but you're looking at those formulas to help you out. Ha! Same thing with 36. Did I do this one yesterday? Super close if it's not the same. Because you were able to go backwards, put it together, say it's a unit circle, and be done. This one's a forwards, though. It was close to yesterday. It might have been a little different. Oh, didn't the problem? For anybody else, is 36 not matching up? You know, oh, I was checking. Number 58. Number 58, is this a verify? Should you put a T-proof on this one? Yeah. Okay, careful, remember they don't do T-proofs because they're lame. But either way, you could have like plugged in, right? Gone to your formula, gone to your unit circle. Check. Number 76 was a solve though. Oh, did they say just a graphic?
They said use your graphing utility.
Ow. That's lame. You could have actually plugged into your formulas. You could have made this nice and pretty and neat. I think it would have ended up being tangent of something. But they had you just graph it, and if you graphed it, you could have found your zeros. And if you found your zeros, it would have been 3.141592. Oh, it's pi. But you could have also solved this by hand if you had used your formulas, if you had plugged into your unit circle like right above. Like you could have done it by hand. They just had you using your calculator to show you something nasty. Ends up really just being a tangent. You can solve.
For number 47, I was looking.
Ooh, okay, hold on. Are we at the end of the evens?
Yes.
Cool. So then coming back to question. Oh, I didn't open the book. Los Santa. Let me get over here. 47. Anything else besides 47 we're looking up? 71. Anything else besides 47, 71?
40.
Okay, so start at 41, then 47, then 71, and see. Oops, sorry, chapter 5, not chapter 4. And then people that did do their formula pages last night that I didn't already check yesterday, go ahead and grab those out because I'm going to zoom around and check them. Number 41 is triangles. How do I know it's triangles right away just looking at the category that it's in?
Oh, because the 5 over 13.
Yeah. Yeah, good. Seeing the 5 over 13, the negative 3 over 5, this is totally a triangle problem because they totally gave me ratios. And they told me where to write the triangle. They said quadrant 2. So I can go ahead and do a triangle with, 13 is going to be long. So long 13, short 5. And then, long 13, short 5. And then, semi-long 5, and then short 3. Okay, so there's my 13, there's my 5, there's my 5, and there's my negative 3. Oh, sorry, that should be a little higher. This one can be a 4, this one can be a negative 12. It might be easier for some of you to do these separately. You could have your 13 and your 5 and your negative 12, and then that would be your U, and then U, and then this one could be your V with a negative 3 and a 4 and a 5, and that can be your V. So then on 41, here's the problem. I don't know who U is, and I don't know who V is. All I know is they're the angles that make these triangles. So instead of going to my calculator and doing sine inverse and finding the weird random non-unit circle decimal angle that makes this, putting it in and using my calculator again. To do it by hand, I say, but wait a minute, I know triangles. And I can use my formula for this to say I can use the U triangle and I can use the V triangle if I just use my formula. Signs stay the same. Jaden, what's up, Ben?
So the question I had, I don't need to do number 47 anymore. So the question I had was like, so for cos V equals negative 0 over 5. I didn't know it's like if the negative went to the top or if it went to the bottom.
It's all based on where they say to put the triangle. So since it's in the second quadrant, I know that the adjacent was the negative, the just by moving within like an x and y axis. You see it?
So, 'cause it's
And the hypotenuse is always positive.
okay, so in which case would it be the bottom? Like that it would be the bottom.
It would never be the hypotenuse because in my trig ratios, hypotenuses, whatever, they're always positive.
Okay, always.
Just the x's and y's are positive or negative, but the diagonals don't have it.
Because that was throw me off.
No, that's a good question. And you knew it had to go to 1. Do you want me to keep going?
Yeah, I was looking at like the book and stuff, and I thought my numbers were right, but it was different.
Oh, okay. So then, but so far so good with the triangles and the labeling. Did you make that guy a negative?
Yeah.
Good. So then we would plug in sine and cosine. And then we would plug in cosine and sine. And remember, we're plugging in, so the trig goes away because sine SOHCAHTOA is opposite over hypotenuse. So I've substituted, the trig's gone, all I have is fraction, fraction, fraction. Then I have to go ahead and just multiply PEMDAS. Multiply, multiply, add. So negative 15 over 65. And then negative 48 over 65, which would give us negative 63. It's okay. But whenever you see fractions, right, on the test, we want to be able to see a problem and know which direction we're headed. Triangles, yeah? 47, Jaden, now you're good?
Yeah.
Okay, and then Emily, 71? Okay, so 71, next page, I think. Was it solve?
Is she coming?
Who, what, where, when, who?
Oh no.
What?
I thought you said she's not gonna be here this week.
Yes, she might.
I don't know.
Joe?
But I'm learning that.
I got lots
And
of
let's
them.
do
Okay, so
some-
71. Solving all, inside. You guys okay if I put up a 0 to 2 pi just so we know what quadrants we're looking in?
Sure.
Ew, gross. Until you use your formulas. Right? So we have co, signs change, minus sine. Where am I getting this from?
The formula.
The formula. I see a minus, and minusing, subtracting, long stuff, I could make seal mistakes. I have to be careful. Remember, if you're doing problems, you should be looking at formulas and making sure you get them right. Signs change. Maybe with memorizing, some of you know that's right. I could distribute my negative right now. That might be a safe thing to do. He's a negative and he's a negative. Oh my goodness, I have like terms. Could we go through and make that root 2 over 2, root 2 over 2, root 2 over 2, root 2 over 2? Yeah.
What do you mean?
This little piece without the x is just a unit circle, good old-fashioned cheater chart. So I could plug in root 2 over 2 times cosine x. That's root 2 over 2 times sine of x with a negative. Root 2 over 2 cosine x with a negative. Root 2 over 2. But what I see is like, wait a minute. Like terms. They're the same thing. So what's cosine x, cosine pi over 4 minus cosine x? Forget that. I'm not even going to write root 2 over 2. Not worth my time. And then I have negative 1 minus another 1. It's negative 1 minus 1. Now, I only have to do it once. Negative 2 sine of x, root 2 over 2 from my cheater chart, unit circle, whatevs. Those reduce, and I believe I get negative root 2. Wait a minute, wasn't this all equal to something?
Why did the red 2?
Oh, because it's just multiplication. So usually we put constants in the front. Like instead of x4, we write 4.
Okay, I get it.
Yeah.
I was thinking
I'm technically just doing like commutative property of multiplication because it's times and times. now I can divide, and when I divide, it's going to be 1 over rad 2, which ends up being rationalized rad 2 over 2. She's nice. That's good. Shh. Rad 2 over 2, and then I move my negative. When is sine negative? Not the first quadrant, not the second quadrant. He's negative here and here. And when is he root 2 over 2? Is at the 45s. So think 4 pi over 4 plus 1, 5 pi over 4, plus another, 8 pi over 4 minus 1, 7. So I have 5 pi over 4 and 7 pi over 4.
I got lost already, like with the square root of 2. Okay, so like
This made sense from the unit circle?
yeah, that made sense.
The 2's reducing?
Okay, so
He's just a constant times. I can rearrange that to make it make more sense.
okay.
That's here. But I forgot equals 1. I hadn't been writing it. So then I wrote that. And then it was a, let's divide by this guy and by the negative.
So you divided this negative square root of 2 to the
Yeah, I should put the negative there. And 1 over root 2 isn't how I'm used to seeing numbers. I'm used to them being rationalized. So root 2 over root 2
Okay.
becomes a root 2 over 2.
Okay.
That's a 45.
Oh,
But I had to think about when is sine negative. Not here, that's everybody positive. Not here, sine's positive. But here and here.
okay. So the square root of 2 over 2 tells you that it's 45.
1, 2, 3, 3, 2, 1, the 2.
Yeah, 45.
Any other homework questions? Did 41, kind of did 47? Did 7 again. So what's our goal? You guys tell me.
To study.
No, like for class. Your
To-
goal for Monday
to
is
work.
study for practice. Practice 5-5 because those new formulas get weird.
Oh, yeah.
Is that cool? Okay. Let's go practice 5-5 formulas. They get weird. And as I get you guys writing down the new examples, oof.
Yeah.
Hey guys, to save time, do you mind if we just do this example and not both of these examples? Is it okay? Can we try to do that? I'm going to get rid of this guy. Not because he's not good, just the other guy's a little bit harder or trickier. So I'm going to try to do 2 things at once here.
Yeah.
Sophia, did you hear anything I just said? Shh.
Pay attention, Sophia.
Alec, you're talking to her.
No, I was not.
Listening to her.
No, I was independently.
I am trying to learn math. Be quiet.
I'm trying to lie.
Do you have to write down these formulas? No. Are we going to use them? Yes. If you have your formula page, should you have it out? Of course. Let me come around and do the half extra credits. So these were the full extra credits. And then we have the half one. Okay, who are my half extra credit people that didn't get it yesterday but did it for today?
I get a quarter of extra credit for the quarter of the day.
Can mine be Monday?
No, for the half? Yes. For the full? No.
I think I should. It'll be Tuesday for a quarter.
On the video yesterday, I said, Jaden, if you have it tomorrow, then it's going to be having it today, so it's full.
I didn't.
I know you did. That's the funny part.
The video was. Can you see whether we watched it or not? Can you see whether we watched the video or not? You can?
If I care, but
Okay.
you guys are usually good.
Well, I didn't watch it. So.
Was there a video for the day that
Yeah,
I was talking to you.
she said if Emily was watching or not.
I use my computer.
Emily never actually watches a video.
Dude,
I did my forms when I was there.
Okay, any other half credit people that I didn't make eye contact with and write it down? Sophia, let me go check it out. I don't know why. Maybe it's not in the playlist. Yeah. What time did you check? What time did you check? Oh, so it should have been, yeah.
I think so.
Yeah.
Every now and then I have someone who says that. If that ever happens, Sophia, email me because I'll just go copy the link directly and see if it works. So you don't have to go through my channel. But it is weird it doesn't refresh. Okay. Oh, so it might just not be. Okay, guys, the example that you have up on the screen doesn't perfectly fit the formulas underneath the power reducing category on your card, on your sheet, in your notes, on my screen, wherever the formula is for you in the book. It doesn't perfect. It does work on your phone. Bummer. Sorry, kid. It doesn't exactly match, so that means it doesn't work, right? Oh, she did the wrong problem. Sadly, I did the right problem. What looks close? What's the closest one to sine to the fourth? Yeah, sine squared. The closest one to sine to the fourth is sine squared. So how on earth do we use the sine squared formula to help us with sine to the fourth? Yeah. Just say, well, the sine squared times the sine squared. If we can't do anything else, we'll break it down as much as we can. We can make that into this. Okay, squared and a squared makes a fourth. So we have to use the formula. So the fourth was hard, and the 2x is hard. I did two hard things in one sample problem at the same time. So now we have to come up here. Please have the formula in front of you. I know it's tiny on the screen, but that's why you have it on your formula page. Because the formula says the following. To plug in for sine squared of u, I'm allowed to do 1 minus cosine of 2u. But that's not going to be 2x. It's going to be doubling what I have, which is 4x. Do you see how the formula actually works?
That's because it's sine to the fourth, right?
Nope. Sadly, that's just this little sine squared piece. And I'm going to have to do it again to get the other sine squared piece.
This is big, bro. What is this?
Why is it a 4x? Because the formula says it's 1 minus cosine doubling whatever's there in the sine squared. See it? So 1 minus cosine doubling whatever is there. If it's just an x, it's 2x. No big deal. But this had a 2x. I had to double the 2x to get 4x. Yeah. Believe it or not. Remember how HPrecalc is like everything future math? Or math showing up in all these different subjects? Knowing how to use a formula can be useful. Not always memorizing a formula, just knowing how to use it. Looking at something and being like, this u, it's literally just like a box I need to plug in for. 2u, plug in the box, whatever it is. This skill is really helpful because your brain doesn't naturally do it until you're shown. Some of you would have known 4x right away. Some of you would have gotten there eventually, and some of you are still like, wait, what? Remember, the formula says sine squared of something is 1 minus cosine of double that something all over 2. Now, here's the struggle. What was the actual objective? Cosine to the first power. Why am I not there yet?
Because if you multiply reverse, you get, you FOIL it and you have 1 cosine squared.
The problem is, even though this looks like a 1 minus cosine to the first of 4x and 1 minus cosine to the first of 4x, in essence, though, in context, this multiplication means
Common denominator.
there is common denominators, but the problem is I actually still have an exponent.
Where'd the 1 go?
First, outer, negative
Oh,
1,
you FOILed them.
inner, another negative 1, negative 1 plus negative 1 is negative 2, last. So even though it doesn't look like it, technically, if I were to show you something like x plus 1 times x minus 3 and say, oh, it's a line, right? No, it's a quadratic because that's a square. Same thing here. It's not cosine to the first power. If you multiply, it has a square. So here's the sad part. I'm not done yet. But I can do something snazzy like, okay, well the 1/4 is fine. And the 1/2, I'm distributing the division across the addition and multiplication. Sorry, addition and subtraction. The cosine of 4x is fine. What's not fine is that dude. So check it. Everything was divided by 4, right? I'm just making more room. So, the 1 was divided by 4. Okay, fine. The 2 was divided by 4. Okay, fine. This guy, the 1 is divided by 4. Okay, fine. But I need to get rid of that cosine squared. And the only way to get rid of him is formula time. I need to do 1 plus cosine double whatever is there. Can you do it this time? Double what's there. What do I get? I gotta double whatever's there. The formula says 1 plus cosine 2 times u. Who is u? I don't know. Whoever's in cosine squared. Okay, fine. 1 plus cosine double whoever's there. Double 4x is 8x. Okay. It's an 8. Can I box it and be done? Sure, but to be honest, they probably want you to like simplify stuff because you're going to end up with the 1/4, which is a number, the 1/2, which is a cosine of 4x, the 1/4 times 1/4 is 1/16, which is a number, and then the 1/16 cosine of 8. There's the clear 8. Clearer 8, oh, because I took this guy. Basically, I see division of somebody as multiplication by the reciprocal. So instead of like keeping this guy around and making a nasty fraction in this step, I just took this guy out and I distributed him. So everybody got him. That kind of makes sense. So one way of saying it, Laurel, is whenever you're dividing, you can always distribute the reciprocal. Well, I'm just going to add the 1/4 and the 1/16 to make 5/16. 4/16 plus 1/16 is 5/16. But sadly, I can't really do too much more without a lot of work because that 4x and this 8x in the cosines make two very different terms. And even though I could keep going by making the 8x 2 times 4x and using a double angle property, I don't think anyone wants me to. So I'm going to stop. And at this point, don't I have cosines to the first power alone? Meaning no squares, no cubes, no fourths? I'm done. Now remember, I did a doubly hard problem. I did one big mama one because I was like, let's deal. You're welcome. Shout out Mrs. Leon. Because the fourth power was hard and the 2x was hard. So I did one problem with 2 tricky, weird things. But do you guys see what the formulas actually mean when they say 1 plus cosine 2u or 1 minus cosine 2u? It's 1 minus cosine double what you had, 1 plus cosine double what you had. Just means double. Tangent would have been even grosser. I'm sure some problems have the tangent. Yeah. Yes. We're now going to go practice half angle properties using, not a rewriting, using a finding. It's kind of like a 5-1 skill. Finding. Finding means like plugging in. Wait a minute. How on earth is this a half angle? That's just 105. Can we just put that in our calculator? No, because it says exact. I can't do decimals if it says exact. But 105, is that in our unit circle? Isn't that 90 plus like 15? Oh. We could try making it an addition. 105 is 45, that's a unit circle 1, plus 55, that's not unit circle. Oh, not even 55, sorry. 45 plus 60. Ooh, I could do that. Oh, except I'm supposed to be practicing these guys. I could have done 45 plus 60 and used the sum or difference formula, sine of 40 plus 60. Sorry, 45 plus 60. I could have done that. Am I supposed to be practicing this? What is sine 105. What's 105 if I'm cutting someone in half?
Oh.
Isn't 105 half of 210? Now, once again, those of you guys that saw this is 45 and 60, and you could have done a sign of u plus b. Awesome. That is one way to solve this. I'm trying to have you practice the half angle formulas. 105 is also half of 210. Guess what 210 is? A unit circle angle. 210 is the same thing as this dude, which is, I believe, 7 pi over 6, 180 plus 30. Should be down. He's a unit circle. He's not. And he has a formula. And the formula is plus or minus. But here's the problem. It can't be both at the same time, so I'm going to put a question mark, and we'll think about which one's right. Figure out which one is right in a second. Plus or minus, square root of, what would the formula tell you to do? 1 minus cosine of the dude you're cutting in half, aka 210, all over 2. I can't do sine of 105, but I can do cosine of 210. Which is the same thing. I don't even know where I'm going. Same thing as 7 pi over 6. So cosine of 7 pi over 6. 1, 2, 3, 3, 2, 1. Square root of 3 over 2 with a negative. This is in the third quadrant. Minus a negative. So we're just using that formula. The formula says, hey, you know a unit circle dude is being cut in half. Sweet, I have a formula for you. So at this point, a minus a negative would be a positive. I don't know about you guys, but we could change that 1 to be a 2 over 2 plus a root 3 over 2. This little baby part could become a 2 plus root 3 over 2. There's a snazzy little shortcut to multiplying by reciprocals, in that you can multiply the outers, multiply the inners, and put them over each other. I was showing regular pre-cal that today. But remember, you could also do my trick of just multiplying top and bottom by 2. You would end up with this exact same thing I'm about to write, which is 2 plus root 3 all over 4. Wait a minute. Don't we know the square root of 4? No?
Wait.
Square root of 4 is
Wait.
2. So we can actually take that square root. I know it's weird, there's a square root in the square root, but it's totally a thing. We could do that in a calculator and it gives us an answer. We're still just stuck with this guy that I've still not answered. Given the context of the problem that they asked me, sine of 105, the formula can't tell me which sign. I need to use my unit circle knowledge to know what sign. What quadrant is 105 in? 3. Careful, this is 180. This is 90, yeah, it's somewhere here. If this is 105, what's my sign in the second quadrant? S, so all students, that means I need to, for this guy, choose what? The positive. 105, the sign has to be positive. But if it was something crazy like, something I know in the third quadrant, when I double it. Something awkward when you cut it in half lands in the third quadrant. When you double it, it's a negative symbol. Anyway, if you were in the third quadrant, you would have to choose a negative, but you're in the second quadrant, so you're going to choose a positive. And that's why in this one, like remember, I'm doing examples just to show you, like, yes, you're plugging in. Yes, all you have to do is look at your formula page and figure out what to plug in. But just some weird stuff can happen. The weird stuff for these half angles is for sine or cosine, you have to choose the positive or the negative based on what quadrant the dude is in, the angle is in, the appropriate sign it should have. You have to know that. The formula gives you a general. You have to apply it to the specific one you have. Does that kind of make sense? All students' sign has to be positive. We could do this guy. I'm not sure I'm going to take time because I want us to practice some of those other formulas. The nice thing is, isn't the half angle, are those the last ones we have to memorize? I think so. I think any other formulas you're going to see from here on out, I'm pretty sure they're product to sum and sum to product you don't have to memorize. So we're done with the memorizing ones. And remember again, with the problems, you get to use your formula page. And guys, a problem like this would probably not be on the test because if you just were given this, some of you said, couldn't you make it 45 plus 60 and use sine of u plus 2? Couldn't you do 210 over 2 and use sine of u over 2? There are multiple formulas to solve this one. On a test, I'm going to be more precise or give you problems that are more obvious to what you're supposed to do. Like over here, you have to use half because that's what they're asking you for. Over there, it's kind of like, I don't know what I'm supposed to do. It's under that. I guess I'll use that. I'll give you problems that are obvious as to what formula to use. Okay. Either in the words or in the symbols. I could give you words. Like, use the sum and difference formula too. So anyway, we're not going to do this entire one, but I just want to know if you know how to start. I see a fraction. What should I think? Make a triangle. And what quadrant based on what they told me? In the fourth quadrant, because 3 pi over 2 to 2 pi has me put in here. And then I know that I have opposite over adjacent. Pythagorean theorem would get me hypotenuse. So now I have my triangle to use. Because these formulas say, I'll get you the u over 2 using the u ratios. Which is perfect because I know the u ratios. I don't know the u over 2. The reason why this is going to be tricky isn't so much plugging into the formulas, although you're going to have some complex fractions because you're putting fractions inside fractions. That's a little messy, but we've already practiced that a little bit today with this complex fraction. What's going to be harder is knowing where u over 2 is to be able to choose this sign. So when you're doing sine of u over 2, when you're doing cosine of u over 2, and needing to plug into the formula from this triangle, whatever trig you need, my question is, well, hold on, tangent, I can just plug into tangent, and whatever sign occurs is the correct sign. So I don't have to choose for him. I have to choose for these guys. So if u is here, what quadrant would half of him be in? I don't know exactly who he is. He's just something between 270 and 360. Can anybody tell me where his half angle would be? Quadrant 1? Do you have like a way of explaining why? I agree. She was like, But can't you like pick something like, I don't know, what's something easy in this quadrant? Like 300? 300's in here, right? What's half of 300? 150. Sweet. What's half of like 350? 175. What's half of like 280? 140? All of those are in. So you can just kind of pick some without even knowing who he is and say, oh, okay, whew, these are all in the second quadrant, which means all students, he's going to be a positive and he's going to be a negative. So that's where this one gets weird is number 1, you have to choose. And number 2, what if you don't know the number? You just have like a letter? Well, if they tell you a range, you can kind of cut that in half. Or cut some of those angles in half to figure out what quadrant, and then say, oh, okay, all students' sine is positive, cosine is negative. So I just wanted to show you guys that idea as far as how to choose the correct sign. We have 2 other sets of formulas. The nasty ones I'm not making you memorize, right? Please don't stress about memorizing them. But I just want to show you how or why it can be useful. Or maybe useful is not the right way of saying it because the usefulness is a little bit advanced beyond where you are. But just how to use them. Do you see how these directions are using the words to tell you what formula to use, right? It's not so much super obvious from the problem. They just give us something. But then they say use these guys? They said to use them. So how do we use them? Well, let me just write, because these are small. Remember, they're written in your book. They're written on your formula page. Let me write the one we need, because we need the one that starts with sine. I'm using this one, just blowing it up real fast. See how he fits? It's nice because they told me to use the product of sum formulas. Go over there and say, hey, I can take something that looks like this and make it look different.
Steve?
Yeah.
These aren't going to be on the quiz on Monday,
No.
right?
Right. But they're going to be on the page, which means maybe a problem might use them for Tuesday. But you'll see things in homework that you'll be practicing with problems. Just keep the formulas right next to you because there's no need to memorize at all. So sine of u cosine of g can be rewritten as 1/2 sine of m plus m. So x plus 1 plus x minus 1. And then plus sine of m minus m. So x plus 1 minus x minus 1. What does that do? It doesn't really seem to. Oh, wait, y minus y cancels. X plus x is 2x. And then this one, distributing my negative, x minus x cancels, and distributing my negative, a negative times a negative is a positive, a y plus a y is a. They're just saying if you ever have a multiplication of trig and it's not working, you can use this dude to make it an addition or subtraction instead. And similarly, there are formulas that let you go backwards and go from adding, subtracting to multiplying, which could be nice in like an equation if it's equal to 0. I would much rather multiplication than addition. But in like a T-proof, maybe the other way. Okay, everyone letting out their classes.
Just Mr.
Mr. B.
Definitely Mr. Grant. Just Mr. Chick.
Yeah.
Why did you multiply?
Yeah, because whenever you add, you don't have to switch the signs. So I just wasn't. But when you're subtracting, yeah. So guys, the only formulas that, number one, we don't have to have memorized, but the only formulas we didn't practice were the sum to product ones. And I would have done an example where it's like, hey, to solve this, there's no way unless we get this subtraction to be put together. But anyway, remember, 5-5, you're just practicing problems. On Monday, we're going to take the formula quiz first thing. So just be studying it throughout the weekend. Be studying it Monday morning. After nutrition, you guys aren't directly after nutrition. You're not going to have me reminding you to study during nutrition this chapel day. We can bust it out. Okay. After we do the formula test, busting it out, memorization, just fill in. Please be ready for it. Then we're going to go ahead and go over questions on 5.5/test review. Remember, in your Google Classroom, the test review has posted. I believe it was this morning. Did you guys see that? Test review is posted, so you can be playing with problems this weekend. So Monday night, you're just polishing. You're not like doing everything for the first time. Does that make sense? Yeah, you're focused. I can help. Come on, bye. Okay, Monday. Tuesday nutrition is the natural, like, I give you the category name, so you know which category, and then I give you, like, this tangent of theta equals, and you say sine over cosine, because it was cosine.
And we didn't know all the ones from chapter 1, section 1, section 4.
5, but not those last two big boxes.
And all the ones in section 4 too. Thank you.
You're welcome.